Hey, Spectre, congrats on the first. Just getting the YouTube stream started. Forgot to do that last time I did this E&M Reading Group, I think, so that's cool. Okay. Sweet. I don't think I have any particular announcements before we get into things. You feel honored? I'm glad, Spetri. So maybe I'll just hop right in voice and we can get cracking. So we have Phobos, who might have Fembox joining us later. Hey, Phobos.
Hello.
How's it going?
It's going all right. Having a pretty good afternoon. How about yourself?
Good. Yeah, I'm basically the same for me too.
Nice. Awesome.
Now, I guess the question for you is, I feel like the last time we were doing this reading group, you preferred to just work on your own piece of paper anyway. Like, was a Discord
Yeah,
whiteboard working for you or not?
I have trouble when I use it sometimes. It's like I'm not able to do stuff fast enough. And then I was working on my own side because I didn't quite understand what you all were doing.
That's fair, yeah. Because Fembox kind of like expressed a similar thing about not being a huge fan of Discord whiteboard, so I wonder if it'll just be easier if we have our own like copies of the work and I'll just like use my whiteboard
Yeah, that should be
and save a
fine.
preference. Okay.
I'll have to figure out some setup of windows here. I had it set up for this whiteboard, but I can look at yours. I think that's better.
Okay, awesome. And maybe I'll show like who's talking. Is there an easy way that I can get who's talking on the stream? Maybe I'll have an idea. Just in case if the Pimox jumps in too, we can see, or people watching can see like who all's talking when. I'll do this.
So if I talk, I show up as a colored box on the screen. Oh, look at that, I do.
Yeah.
Here we go.
Okay. um. So I guess let's go and choose a problem.
Yes. Did you say that you had worked on one, or was that Fembox?
Um. Did I work on one?
I think the answer might be no.
I guess
Might
no.
be
Yeah.
Fembox said they did something. It's in here somewhere. I can find it. I possess the ability to read. I'm gonna
That's
use
good.
it right now. This is amazing. 1.39.
Oh, that conversation. Okay. Oh, Invox said it was a cool one, right? You can try that one.
Yeah.
Okay. Also, hey, hard locked. Got a rhombus of charges.
Sounds like a pretty cool band name.
Yeah. Wonder what kind of music? I'm thinking like EDM or something.
Yeah, I think it fits.
Four positively charged bodies, two with charge Q and two with charge small q, created by four unstretchable strings of equal length. Forces they assume the equilibrium configuration. Okay. Show that tangent cube theta is q squared over q squared?
And obviously, it can be done two ways. I mean,
Of course.
obviously.
Yeah. It's trivial, you know, we don't even have to show it because it's so obvious. Cool.
And they tell us, okay, yeah, that comes
Oh, with
next.
force or potential energy. Okay.
I wonder which one is more like directly clear. I wonder which one.
mean, I'm thinking about, I guess, the force first. Like, if we want to get to tangent of theta, we would need to work out, I guess, the horizontal force and the vertical force. Or like, where, like, how do we even like involve tangent of theta in the first place? I guess.
I think I need to reread the problem just a little
Same.
bit. 4 positively charged bodies. So you got different charges. Okay. I thought one was negative because it was little case, but that's not what that meant this time.
Right, yeah.
Okay. So then assume like, let's say you just picked up all 4 of those things and the strings and just like crumbled it in a ball and let it go. Presumably, based on the question, it should form a rhombus. So
Yeah.
we have to find... It feels like there's 2 things stopping the movement. The tension in the wires and the length of the wires. But do we get the length of the strings? They're just equal length.
No. So yeah, we could call it L, I guess, but
Or just 1.
yeah. That's easier.
You know what? Let's make it real easy. Let's call it 0.
It's all one big point charge.
Yep.
Uh,
So I would go with a 1, just to like simplify everything. It should. If the length truly doesn't matter, I would think about that. All right, I'm drawing a picture of a rhombus.
Hey, Ali over on YouTube. We're studying electricity and magnetism. We're pretty early on, so it's just electrostatics right now. This is all just like for fun. What we're working on. Okay. How's this part gonna work, I guess? That.
Would we be able maybe to think about just one point here? Like focus on the force at one particular point and show that it evens out. Evens out as in the electrical force and the tension force are even for that point. So there's like 3 electrical forces acting on the 4th charge, and then 2 tension forces acting on it.
That seems reasonable. And like you can think of it by symmetry about what the rest of the rhombus would look like.
Or do you think maybe we have to think about the whole system as a whole? I'm really not sure.
That's, yeah, it's a good question.
Or maybe if you think about it in terms of forces, you can think about it one way, but if you think about it in terms of potential, you have to think about it as a system. Like potential energy in the system. So the potential energy, assuming that the points are static and there's no like wires holding them there, that should equal the tension in all the wires, right?
Right.
Or the energy of tension in wires, which I have no conception about calculating.
I Yeah, I mean, I think if we go with your idea and like we chose like, just that charge on the left to calculate how the force is on, we could say that the two strings or the wires above and below are the exact opposite of that force, and they presumably are taking the load evenly. So we can figure out just that one wire that goes with theta, that's the hypotenuse of the triangle. But that would be the force in the wire, not necessarily the length of the wire. But if I call it charge on left, charge 1.
Your mic is acting a little funky when you're away from your, I think, computer chair.
Shoot. It's because... Oh, why would that be?
It's one of my favorite sayings, technology.
Is it better now? Or
It's
do
louder.
it's like if I'm away for... Are you able to hear me now when I'm away?
I can hear you when you're away. You're significantly louder. No, I
Oh,
can't
shit.
hear you. No, wait, I was looking at the Twitch video. Can you speak one more time?
Yeah. Can you hear me now when I'm away?
Sort of. It's crackly, like kind of breaking up a little bit.
No.
So just rearrange your house real quick and
um... Okay. I just switched to my other mic. So hopefully this one isn't crackly at least.
it sounds great.
Okay. I'm gonna use paint or something then, because I guess my lapel mic just isn't feeling like working right now.
Tisk, 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 microphone.
Yeah.
I'm going to share a picture in Reading Group text chat.
Sounds good.
Oh boy, that looks funny. But hopefully it's readable, maybe? Let me try a different picture. That's better.
It does look funny, but that's pretty much what I was thinking too.
Yeah, and the one thing I noticed is for the top and bottom
Hey,
red
Pembox.
force vectors. Hi,
Sorry.
Pembox. Oh, for the top and bottom force vectors, the red ones from the picture,
Right.
those ones will have length or distance 1 away from the little q charges, but it'll have distance like the width of the rhombus for big Q to big Q. So that should help us get one of the, what's it called, the sides of the triangle. We can find hopefully the distance or something that relates the distance between big Q and big Q, or little q and little q. That could help us maybe find one of the sides of the triangle with the theta in it.
Um, Yeah, I'm still getting a little like I don't know how we'd actually, or and I'm sorry if you said like how we do that and I just wasn't following, but like we could definitely get the force on this, just like plugging things in generically, but we'd have to somehow relate the force to the length, which I guess is maybe, oh, and that's what you're saying with like, we know it's going to be a diagonal or a side of the rhombus, I guess.
Mm,
I'm not sure if this is, sorry, what?
I don't think I followed your sentence.
I'm not sure I followed it either, to be fair.
Okay.
um,
The thing I'm thinking of is we'd have to do it like the equations for these forces are component-wise or vector equations, right? So, but we should be able to use symmetries to get them down to like individual component-wise, at least in the x direction.
yeah,
Because
the
you know the
net force is
y.
just straight left on this thing.
Yes,
Yeah.
because of the vertical symmetry. Or how would you say that? Well, you can fold it lengthwise. One of those two.
Okay, what would we call the length of this diagonal? Like the horizontal distance across.
How about big L?
Oh, if we're calling the side length of the rhombus 1, shouldn't we be able to figure this out? This feels
Well, it's
like a
like an
geometry
unknown
problem.
until we solve it, right?
Hey, milk, alpha length of string. That would make sense to me, but I guess
I'm really not tied to the idea of using any particular letter.
yeah.
So whatever makes sense to you all. D sounds great.
So we should be able to use, like, we do have theta, so we could use trig to get the length of the long part. Because we want, like, cosine of theta. Say it's 2L cosine theta. If we make L the length of the string, at least, would be the horizontal diagonal. Because just L cosine theta with right triangles is like the, it's half of the diagonal. I don't know if this is going to help, but if it's like we at least have a theta in there for part of this. Q squared. Cosine theta.
Wait a second, how did that okay, I get it.
Okay. But like, we want this to be equal to something.
The tension
Right.
forces, right?
I guess so. And hey, Pauco? If it's something I can with calculus 1, yes, I can. Not right this instant, but if you check back in like an hour and a half or a bit more, I'll be switching to just regular like math help stream. And if you need math help in general, let me shout out a few channels here for you. But yeah, I can definitely help out with Calc 1, just not right this instant. It's equal to the tension forces of the two strings. So
I wonder if SPQ takes random questions.
I'm
I'm not sure, to be honest. I haven't asked.
not sure either.
Seeing we do the little Q particles now.
And then come up with a system to solve? I'm not sure. I'm still working on the triangles. Stuck on triangles.
Yeah, this was a nice problem because it had some geometry in it too. It's so sad I had to remember how a rhombus worked.
I don't know, they work right now. Thanks for the follow, Palco. Oh, and thanks for the prime, Palco. Wow. And if you want, you're also welcome to post questions in the Discord too. And if I can't get back to you on stream, I'll like get back to you via Discord. But it's completely up to you. If you want to just stay in chat, that's completely fine as well. I wonder if there's some kind of claim, since these two big Q forces are pushing away from each other stronger, should the length of each of these diagonals like be the same as the ratio of the forces? Or maybe like the square, or like the square root, because the force drops off with r squared.
I mean, that says to show something that seems like it's like in a 2/3 power ratio.
Yeah.
Yeah, because I assume we
So
get
we're
like...
there.
Sorry.
Oh no, I was gonna make a joke.
Oh, well, I'm sorry I interrupted. I assume we'll somewhere get like a tangent equals, I guess, q to the 2/3 over q to the 2/3 or something, and then we'll cube each side. So I feel like we get some kind of funky fractional power somewhere. I guess, would it help if we run the force on one of the small q's? 2k qq. L apart. We want sine theta for that. Plus k small q squared 2L sine theta. And I think we want to do F2 over F1. I have a hard time explaining why though.
Still working on that triangle.
Okay, I'm just gonna try it and see what happens on my end at least. Oops. Beta. No worries, Milk. I think what I just did is bad. All the L's are canceling. I don't think I'm gonna get much that's helpful from it.
The L's
Should
should
they?
cancel, right? They don't give you the length of the strings. So, like, hopefully it shouldn't matter.
I thought it'd be helpful if we want to get a tangent theta, because I guess tangent doesn't rely on L, does it? I guess if I just roll with it, what happens?
Following my life motto. All right, I think I got your same equations. Feels good.
Oh, cool. By sine squared over cosine squared to get rid of those denominators. I guess 4. I mean, I like to investigate both ways, Milk, but you might be right that the potential energy way is easier. It'd be nice to be able to work it out both ways if I can, though, or if we can.
Wait, have you found the tensions is?
I guess not. Is the tension in the rope like? I guess when we add the force together from like a big Q to a little q, like each of the forces added together is a tension on the rope connecting them. I don't know exactly how that works. What?
I mean, all the charges should be pushed apart, so then should hold a tension on those strings, and those should stop it from moving. So those tension forces, as vectors, should add together to equal the electric forces, as far as I reckon.
Yeah, I'm just a little weirded out because like our calculation for like the big Q on the left includes the force between the big Q and that small q. I feel like it's like being double counted. I don't know if that's right or not. Maybe it is right.
I think it'll cancel out, and you're like left with just the big Q piece. Because actually, I don't know.
I feel like it shouldn't
You know
cancel.
how much force the electric is putting on there. So actually, no, we know how much force all of the other three charges are putting on the left charge. And then we can distribute that conceptually to the strings as force. And say there's this much force in those. But I don't know what that gets us now. I thought it would get us something, but now that I think of it, not sure it does, just on its own. But if we had it for both, like both reference charges, like the top one and the left one, maybe something will come out from that. I'm not sure.
Hmm.
Fembox, which way did you do it?
I first tried to use forces like you guys are doing, and I didn't just, so it looks like what Dawn's got on the screen is like F1 was the X component of the electric forces on capital Q, right? And then F2 is the Y component of the electric forces on lowercase q. That's what it
Right.
looks like. Yeah, what I did was I tried to, I sort of took your, on your picture there, your red and blue arrows, right? Along the string. I sort of added those two red and blue arrows together and just thought of it as a single force. And I thought of it as the electric force minus the tension. And so instead of 5 forces, that way I could get 3 forces. And then once I had it to 3 forces, I just made a force triangle, you know, like if you've got 3 forces, they have to close, and it's in equilibrium, they have to close a triangle. So that's what I tried. And then I still felt kind of some despair because I was like, what do I do with this? There were so many unknowns. I felt like I was stuck until I thought about trying the lowercase q, right? And then I had 2 equations. And then it kind of just magically worked at that point.
Huh.
I'm not sure if your F2 over F1 down below is going to work though.
I
I'm
don't.
not sure if
Yeah.
that works.
I think there should be a ratio somewhere in here, but I don't think I got anything helpful from doing this.
Because I feel like the tensions, you haven't taken those tensions into account, and I feel like the tensions, I don't know how they work in that ratio. I assumed several things by symmetry, right? I mean, I assumed that those 2 blue forces would be equal tensions in the 2 strings in magnitude, you know?
Yeah, I would assume that as well.
I felt like that was fair.
What I wrote is so okay. I'm getting confused on how we'd figure out the tension in the string. I guess.
I never actually calculated it because I could sort of factor it in with the electric force between 1 and 2. And I sort of just kept it in with it. And then in my system of equations, it was with it in both equations, you know, and so it just kind of fell out, and I never had to calculate the tension.
Hmm. And so, were you saying that your equation was for like the total force? I guess maybe the things that I wrote are the force only from Sicario. Thanks for the follow. The thing that I wrote is the force only from the electricity or the electric fields, but you're saying you also added in things for the tension?
Yeah. And I wasn't doing X and Y components. I just sort of drew a force triangle. It's kind of my way of doing these problems now with 3 forces. When I have when I can get 3 forces on an object and I know the object's in equilibrium, if I sort of know the geometry of the forces, then I want to just draw a triangle, a closed triangle, and then use like law of sines and law of cosines to try and, or, you know, trig and stuff to get through it at that point.
I didn't know that they had
So
to
let me
make like a
see.
closed triangle.
So I'm looking at the triangle I got on my paper and comparing it with your equation for F2. So yeah, exactly, something like that. Except where you've written string, I'm thinking of like string plus field, because each
Oh,
one of
really?
those string sides is a string plus as well as a field.
Oh, they happen to be canceling, but okay.
Yeah, they don't completely cancel out, but but they're working against each other.
I'm not sure I understand that. Like, is it the entire field or?
So if you
Because
look back at Phobos's picture, that's going to be like the string is the blue arrow, right? And the field is that red arrow. So put them together and you get one force in that direction.
oh, okay. So like, it's just like the charge from one of the small cues, or the
Yes, just
okay, yeah.
yes. Yep.
Um, Guess I'm still not sure what you do with this. Because I think we ultimately need to figure out the ratio of the side or of the diagonals of this rhombus. That's the only way I can think of how we figure out what tangent theta is.
So that little triangle you just drew, you know something about its geometry, right?
It's isosceles, right?
Yeah. But we know, yeah, so the top two sides those are equal length. But we also know the angles, right?
Um, I mean, I know that. I guess the bottom two angles are both theta.
Yeah.
Okay.
Yeah, because when you add those two, the blue and the red arrow, we don't know the magnitude now, but we do know the direction.
Sure. Yeah. I'll be back in like 1 second. Okay. Hey labs, what the sigma? Is that like a math version of like what the hell? We're doing some physics studying. Okay, maybe I'm still kind of stuck on dividing the forces, but I'm thinking if we had a separate problem where all four of these were small q, we would just get a perfect, like we would just have a square, not a rhombus, right?
Yeah.
And so if we made two of these charges on opposite corners into, you know, big Q, I'm just kind of imagining this thing stretching into a rhombus, and that stretch should be proportional to the difference in forces. And I guess maybe that's why I keep wanting to just like divide things, or like divide the forces. I don't know how we actually like get that tangent theta to pop out though. But that's why I feel like it's justified to do something with getting the ratio of the forces.
I think if you find forces in the y direction, they have signs in it, right? So
Yeah.
you found forces for the big Q on the left. And if you did the same for the little q, you'd have something with a sine in it, and then sine over cosine. There's a tangent. It falls right out. And the L's might cancel too. But I don't see a way to get there, personally.
Yeah, because when I tried dividing them, it wasn't so clean.
Potentials it is.
Yeah, I'm down to just try potentials, I guess.
I'm not experienced enough with these sort of force problems and setting it up and working them. I tried to work one with a basic like pulley the other day. It did not go well. So I have some
That's
fundamental
fair.
studying in mechanics, I think, that I need to do personally.
I would also need to do it. Ugh.
Yeah, the reason I thought this problem was so nice was because the force method was difficult, and I got halfway through it and I was like, I don't know if I'm gonna get there. And I kind of felt lucky when all of a sudden everything canceled out and it worked somehow. But then I went and looked at potentials, and it really was, well, I'll let you guys try it. I mean, I was surprised, let's put it that way.
Well, I guess an easier method we shouldn't stick up our noses at.
At least now we know why we want the method.
Yeah. So to do this, we need to count every pair. Sorry, what was?
I was gonna ask if you've ever had anybody try to give you advice and you're like, no, I'm gonna do it my own way. And then you learn why.
That's my entire life story right there.
There we go.
So potential for 1, 2. It's the equation is like k, the two charges, and then over r instead of r squared, right? We don't have anything special for potential energy. Need to go back.
Just 1 second. I remember there are the two different ways for calculating that. One you had to half it, and the other one you did not. If you count the pairs diligently, you don't have to half them.
Oh, yeah, so like we would be doing the summation version with the 1/2, but since we're just doing manual counting, I don't think we need the half. Okay. Um, 2, 3. Q over R. 3, 4. It's K, Q over R. 4, 1. It's K. Oh, wait. I keep just using R generically. I should, I guess, use L for consistency if we're going to call that the side length. Hey, Nail.
I say go wild and make it 1.
It makes me nervous.
Pre-cancel. take a pre-cancel.
You can do one on your end. I want to do it with L though.
L's, ones, they're all the same.
Yeah. Just take off the bottom part of the L. It's a hidden one.
And for the big Q interactions, those would be 2L cosine theta still, right?
Yeah. I like that. Oops. Small q squared over 2L cosine. Nope, no, sine theta.
Is it sine now?
For the small q's, yeah.
Oh, right. I was forgetting about those. I was living in Force World over here.
Do we just derive this for theta? Sorry, differentiate. Femux is here.
Oh, I almost jumped on you. Wow, I was ready to jump on you.
They're saying to minimize u. And our only variable is theta. Yeah, and these first four are just constants.
What's the rationale behind taking the derivative?
So, the hint, basically.
Oh, the hint. Okay.
To minimize it.
Oh, right. Minimizing it. Makes sense.
Is that going to be a 45-degree angle? That will be a square, though. Never mind, it can't be. Or what's going to happen with this? What is this thing going to derive to? Differentiate.
Derivative of secant is, what is that? Secant tangent?
Oh, you're right. I was just going to do the chain rule and be annoyed. That's easier, though.
I've been studying. At least I studied that. Got that going for me.
Secant theta, tangent theta. The real test is if you know for cosecant.
I was just thinking, I've forgotten it. It has been like 2 days since I studied that, and it just disappeared.
I always have worth remembering it. I assume it's gonna be like secant tangent, but negative and with cosecant and cotangent. That's my bet.
Yeah, that's it.
Okay. And we'd set this equal to 0, I guess.
Got lucky, Don. You got lucky.
I really did. Oops, not t. So we get secant theta tan theta equals cosecant theta cotangent theta. That's annoying to solve.
Is anything?
Wait a sec.
go
Something's
upstairs.
missing.
Is it? Oh, the Q's. Hot. I got too enthusiastic with canceling constants.
I say roll with it, Don. Just cancel it. Cancel out a cosecant as well. Just
Yeah, just for fun. Okay.
and I think you just collect terms and then magic happens.
Oh, yeah, probably. Probably better to not use cosecant and cotangent. Just to work out the fraction math.
I like that. I'm going to use that fraction math.
um, over cosine theta, sine theta. Oh, it does work out to be tangent cubed. That is so much easier. Wow.
I think he had that reversed. I think it just needs to be the reciprocal. That would be cotangent cubed.
I do have it flipped. You're right. Wait. Oh, did I flip something else then? Oh no, they do small q squared on top. Okay.
Yeah, just flip it, and then you got it.
Okay.
That feels like an E&M thing to do. Yeah. We got an answer. Just flip it.
Now, isn't that beautiful how simple that was?
Yeah.
I mean, it was so easy. We didn't need any vectors.
How many stars is this? So I still want to figure out the force way. It's 2 stars. I feel like the potential energy way is 1 star and the force way is 3 stars.
And then it's the
Took
average.
the average, yeah. Okay. Maybe we'll leave the force part for another time if we want to find a new one, or let's want to say anything else about that problem.
Yeah, I'm good.
No, that was the reason I wanted to look at it, because I just thought it was so nice to see how easy the energy method was.
Yeah.
I know they've said that before, right? Like some problems, it's just so much easier to work them out using conservation of energy or energy ideas instead of force ideas. And for this one, I was amazed when I finally got it with the force approach. I was like, oh, let me try the other way. And it was like 2 lines. And I was like, wow.
Just wait till we get to use Gauss's law. Symmetry, Gauss's law. Everything's a line. The answer is 0.
That sounds nice. Um, $57 might be interesting. Drawing field lines for a system.
Yeah, let's try it.
Didn't you do that one?
Did I?
I thought so. You did something really similar to that.
It did.
Or
It did feel a
maybe-
bit familiar, but I think it was a different problem.
Look
A
at
lot of these
laws.
problems kind of feel like they're a little close to each other, which is fine with me.
Oh, it was 1.9, I think, is the one that's different.
Okay. See, I don't remember drawing field lines, so I think this was different. And hey, Rebel Wolf, how's it going?
Oh, like is the setup in this problem the same as the other one?
It is the same. You're right. You're right. I just looked at it. It's 2q is at the origin and minus q is at x equals a. That's the same setup for question 9.
I'm just gotta draw those field lines.
I should remember what the answer was.
Find a point on the x-axis where the electric field is 0. Yeah, that was question 9.
Um,
And then the second part of question 9 was find a point Consider the vertical line passing. Well, anyway, and then the problem changes a little bit.
Yeah, it's interesting, I guess, the drawing part and the Gauss's surface part. So
Consider the field lines that form the cutoff between these two cases. Nice.
yeah, I assume there's some kind of shape that you can draw that's going to show a lot of cancellations somewhere in this problem. Not too bad. That's good to hear. Rebel Wolf and Epic Flag in the background. Ooh, thank you. Oh, that's awesome. So we've got 2q at the origin and minus q at x equals a. I'll say a0. So I assume the point where the fields are equal is going to be, or where the fields is 0 isn't going to be that bad. K to q over x squared. K minus q x minus a squared? I think that's good. Okay.
Yeah, looks good.
And now just set these equal to each other, or make them add to 0. K 2q over x squared plus k minus q x minus a squared equals 0. 2 over x squared minus over x minus a squared is 0. X minus a squared. 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 Okay, that's really messy writing. Okay, and then quadratic formula.
Well, yeah, I'm keeping up on this one. I'm right there. Same spot.
Nice.
But not if I keep talking. Damn
it. No, keep talking. I want to win. It's a race.
It is a race. It really is.
32a cubed? I guess so, yeah. It's really hard to do the quadratic formula when there's an a as a coefficient. I'm like, wait, which one is a, b, and c?
I don't get 32a squared.
It's
Or a cubed. Did you end up with an a cubed in there?
It's 4. Oh my god, I made I made the same mistake I was just talking about. It's 4ac, but it's not the a that's in the problem. It's 4 times 2a squared, so 8a squared. There we go.
All right, we're at the same.
Awesome. Factor for root 6? That's a weird number.
And I get minus 8a squared there.
Oh, because I didn't fix the minus sign. Is that a less weird number? Oops. Four minus two is two. Okay. That seems reasonable. Do we
Yeah,
want both these
same one.
solutions?
I think
Okay.
so.
Find the point singular on the x-axis where the field is 0.
I think the case where you have the subtraction, it's not valid for some reason. I don't know why it's not valid, but like that would be 2 minus square root of 2 times a. And that should be less
Yeah,
than 1, so it's less than a.
and
Which
it's
is
certainly not
problematic.
0. Yeah.
Yeah,
Okay.
that would imply the force field is pushing right towards the one side. There's
Yeah,
no stable point between the two.
I like that. So we take just the positive.
But then why? Why did we get 2 answers? Usually that means there's 2 answers.
I mean, I'm thinking about it like with like mechanics. I remember having to like work out the parabola that a projectile follows, and you figure out where it hits the ground on like the right side of the parabola that's facing down, and you just throw out whatever one is on the left in the negatives. I feel like that's kind of common to throw one of the solutions out.
Doing peak physicist. Love it.
Uh, that's not a very good justification for this situation, but I feel like it's okay that we throw one out.
Is there any way we can validate this? Does that diagramming or that website that you showed where you can put the charges around
Oh,
have that ability?
we can try.
I'm a sucker for a picture.
Same.
Yeah, me too.
2D electrostatics. That seems reasonable.
When I take the GREs, I'm going to write proof by picture. And I'm going to get full credit.
I mean, for multiple choice, that's probably a good call. I have these. Wait, this is the right orientation, right? Yeah, 2Q on the left, minus Q on the right.
Oh, this might show us field lines too.
Yeah, because we don't need the equipotentials, do we? I guess if I shifted this to the right, we'll see the 0 part over to the right. Yeah, I think the field is only going to get stronger between them. I guess it's going to be strongest closer to the positive charge because it's 2Q.
Should be
I don't
like
know.
asymptotic near any of the point charges.
You're right. But one is more asymptotic.
You know, just more. About twice more.
Mm-hmm.
So that point where the line ends, is that the point?
I think so, yeah. And like the green arrows, like there's a spot, like there's really faint green arrows to the right around it, but there's like just a black spot.
Do you have a ruler?
Can you zoom out?
Zooming out does not seem possible.
Okay.
I do have a ruler though. If I go and grab it quickly. 1 second.
Physical ruler. Nice. Love it. And then that would be just so awesome if it actually measured to be the right thing. So like 2
Wait,
plus
where's
square
this thing?
root of 2, what is that?
Oh, here it
It's
is.
like 3.4 something.
Yeah. Yeah, that rings a bell. It sounds like what we got last time we did this.
3.414. So
Are you already measuring it?
no. Just the number that it should be, factor of a. So we need to find the distance between the two charges and then the distance to the point where the
Ah.
field dies.
It's
Horrible death.
gotta be much further out, doesn't it? If that distance there between the yellow and the blue is 1, and we're trying to go out to 3, that's never 3. 3.4.
It might just be right at the edge, maybe, just maybe.
I was going to measure this in inches, but we're doing physics, so I'm going to use centimeters.
No, use dynes.
Measure it in force? Okay.
I don't care if it's the wrong unit. We're gonna do some physics.
This is a little bit of eyeballing, but I'm going to call distance between the charges 3.8 centimeters. In the distance, I guess from the positive charge to the 0 spot. Oh God. 8.5 centimeters. So 8.5 over 3.8.
Should be about 13.
5 over 3.8. 2.23? That's not 2 plus root 2, is it?
Not quite.
Did I
So
measure that right though?
I mean, the charges was 3.8 centimeters. It should be about 13 centimeters away.
Oh
What
no,
if you
I
crank up
measured them
the-
both from the positive. If I crank up what?
What if you crank up the charges from 2 and 1 to 20 and 10, maybe?
Sure.
I don't know if it's going to make the picture different.
Oh.
I just thought maybe it would.
It's a lot brighter. So that does make it more obvious where things are, I guess.
Yeah, look, it is showing a 0 where that line ends, isn't it? But it doesn't seem like the right. Did
Yeah,
we
let's-
make a mistake?
What have we done?
Well, this was an answer, or this is problem 9, right? The same exact setup, so we go check the answer for 9.
Okay.
Oh,
I
yeah.
thought I got 2 plus root 2, though. That sounds familiar when I did this problem.
I know it does. I thought it sounded familiar too.
Okay, yeah, it is 9. What page is this? 650 wasn't a bad guess. 620?
I'm gonna see if I can't.
It
whip
is
up a
2 plus root 2. Oh, wait. 2.41, x equals 2.414a. Oh,
Oh wait, that's a mistake, isn't it? Didn't we say before that was a mistake? It should be 3.414.
Oh, yeah, that's a typo, isn't it?
Yeah, now I'm remembering. Didn't we say that? I think when we looked at it.
I don't remember noticing that
mean-
before, but it's definitely 3.41, yeah.
Or maybe I just noticed that when I looked at it. I think I remember noticing that. Well, what about that bring that picture up? But it doesn't look anything like 2.4 or 3.4 times that distance, does it? On the screen there. It looks more
doesn't.
like about twice the distance.
Yeah, by measuring, I got 2.2 distance. Is it something with the construction?
Yeah. I don't trust this applet anymore.
Oh, wait. They said they calculate fields with 1 over r for some reason.
What?
I forgot about that. I don't know why. Yes, this is the 2D simulation. Electrical charge is proportional to 1 over r, not 1 over r squared, and I'm not quite sure why.
I think I have a visualization we can measure on using the stuff I built the other week.
Nice.
Oh, yeah. I think they're treating these like infinite cylinders, and we're just taking a cross section. I don't know why you would do that though.
I mean, even if it's a cross section of a 3D, you still use 1 over r squared, though. right?
I don't know
I think
why.
maybe they're going for
I think you
qualitative
would.
diagram,
Oh,
which sucks. I added. All right.
wow. What are we looking at now? Black hole.
It's their 3D simulator. It doesn't let you. It's not as customizable as the 2D one. I can't add things arbitrarily. They only have like presets that you can look at.
Okay, I posted one in the group chat.
Oh, cool.
The text channel.
Yeah, look at that. That looks nice.
Oh, that was quick. Wow.
That's what
That looks
happens
much
when
more
I've
like-
already written the code. I don't have to write it from scratch again. It's amazing.
Yeah, look, it doesn't that look like 3.4? Get your ruler out there, Don.
Yeah, I mean,
Check it.
I guess we could just measure it in paint or something too, but this is more exciting.
Don measures stuff.
All
It's great.
right, I'm gonna say yellow to yellow is 2.3 centimeters, and the left yellow to the black dot is 7.6.
I get 7.8 if I do the arithmetic with the computer.
Okay, well we can do 7.8. I forgot the first number I said now. 2.3.
Oh yeah, it's 2.3.
Yeah.
Okay. 7.8 over 2.3. It's 3.39. That's pretty close. Unless I
Nice.
misremember the numbers again, but yeah.
Yeah.
Okay. Yeah, it's just that one over R thing. There must be a reason why that is a good idea for them, I guess, but I wonder what that reason is.
I mean, I guess you could say it's probably more computationally efficient, but I don't know.
Maybe, yeah.
Okay, I think Phobos' software is better than that other website.
So far, I agree, yeah.
Finally, for once.
Now you got to add more functionalities like field lines and equipotentials and all that.
Oh yeah, I'm working on it. It's very slowly.
Why have a program to make the field lines when we have to manually draw on the field lines for this next part of part A?
I think I have
I
a
guess it kinda
sample
cuts
where I
through.
actually set up the field lines. I might be able
Oh.
to whip that into this setup as well. But
So when you think about it, like the field lines would be, because the colors are, how does it work? Colors are based on like the gradient, aren't they? So like the yellow is the strongest,
yeah,
and then it
it's
fades
strong.
out towards green and blue and purple and black.
Yeah, think of it like heat vision.
Yeah.
It kind of uses that color scale, except for stops at yellow for some reason.
So doesn't that mean if we wanted to find the field lines on your picture, we just have to stay on the same color, right?
Yeah, that's conceptually,
Yeah.
I think, true.
Okay.
And that would mean the magnitude is the same.
Oh,
So, yes,
Yeah.
I think so. Do it with paint, Don.
I'm kind of losing a little bit of confidence now. But I'm actually like, it's like, what shape is this exactly gonna have? It's like the food lines, like on the back side of this positive charge, get a little crazy with how they loop out and really slowly come back in. So I don't know if that part is even like quite right. But there should be like a gap here that I guess is the important part. Well, I guess way out there. Be more proportional, but I don't know, does that field line straight out just never come back in, I guess? I don't think it would.
I think the field
Right.
line actually, the one on the right, I think, goes toward A.
Oh yeah, I guess there would be one on the right, but it wouldn't be infinite. Like, after a certain point, there'd be like a discontinuity.
Yeah. Yeah.
It'll be further out, because I'm not doing things proportionally, but...
Actually, which direction would that arrow on the right point? Does it point to the right? Like the one further out past that?
Oh, I have the
No.
directions flipped, maybe.
Well, I'm
No,
just
they look.
curious.
No?
I think they look right. I think they look right.
Yeah, it would be weird if it pointed the other direction, but I just wanted to be sure.
Because once you get far enough over to the right, you sort of think of it as like a positive Q point charge, don't you? You sort of think of the
Yeah.
plus 2Q and the minus Q become just like one big plus Q.
I like that, yeah.
At a distance, everything's
At,
solvable.
at
with
a
calcs.
at a long distance, yeah.
Okay.
Yeah, so if you're on the right, if you're past that black dot, if you're to the right of that black dot where the E is 0, then you're going to keep going to the right. Your field lines would point right after that point.
Yeah.
You know what
Okay.
this reminds me of? This kind of feels like a bifurcation problem from differential equations, doesn't it?
I don't think
It
I've heard
kind
of
of feels
those.
like a bifurcation to me. It's like you got some parameter, and if you vary it, you're going to change the outcome of the system somehow. There's going to be a point where like the long-term behavior changes or something.
Oh, like a chaos thing?
Yeah, maybe it's more like that. Maybe it's more like a chaos thing.
I know hardly anything about it, but I do think it's interesting.
You know what? Oh, you know what? Wait a second. I think I got an idea. What we could do is we could try and find a field line that would come in and terminate on that black dot. Wait.
I don't think any terminate there. I think it's like a source of field lines.
Yeah.
Oh, but there would be some change in behavior. Try to think about like from that 0 spot. What would happen if you take the you have a vector to the left and right pointing, or field line to the left and right pointing in either direction. What direction would the field lines point when they're like rotated a couple degrees in either direction? Like what part of the field line is that? Near that point of no electric field.
I'm not following what like the setup of this is.
What would more field lines near the 0 electric field spot look like?
Oh.
But like close to it.
I
think the
imagine it would like there'd be some kind of like diverging like I imagine just things like bouncing off it.
Okay.
I guess.
I think the simulation with the picture that you did first might be able to show that.
Yeah.
Even if they use a inverse, not square.
It would at least be the right concept. I have to set it up again. Yes. Oh wait, let's crank it up to 20 and 10. Make it more obvious. Oh my, we got the sun here.
Oh, wow.
Why is that so much brighter? Oh, because of the equal potentials. There we go. So very close. They do kind of bounce. I mean, it's not quite that clean though. If I choose an individual path, it seems like I'd start on the left here and trail off to the right sometimes, depending on where I start.
Mm-hmm. Oh, that's interesting.
So it's not quite as
Is there any
simple
way
as I
to
made
tell
it.
it more field lines, please?
Vector density. What about vector density? If you mess with that, what does that do?
I think more resolution. Oh my god. Ooh. It looks
Wow.
cool. Brightness, equipotential count. These aren't perfectly in a straight line either, but feel.
I mean, they should be. There's 2 points. Always
Well,
makes
okay,
it
yeah,
right.
there is like, oh, that's a cool one.
Whoa.
Um, that's not helpful. But just like the field lines are, or no, not that. Like this field line up here makes you think that they're not grouped in a straight line, I guess, or like they're not grouped to that correspond to the x. I don't know if I can like. I can't just like type in a position, unfortunately. But it shouldn't be that important, I guess.
Yeah, some field lines go off to infinity over there, which makes sense. But
Yeah, they're at least warped, I guess, but they never come back in. Huh.
Oh. Oh, wait a second. Here's an idea. Ah, this is nice. Every field line has to start on a plus charge and end on a minus charge, right?
or
Not these
go
ones on the
toward
left.
Well, but what I mean is, or they can go to infinity, right? So you got to imagine at infinity, they can always start or end there. But so every one that's going to be closed is going to start on the plus and end on the minus. Ah, and then can't we argue that the number of field lines is like the flux, right? Which is proportional to the enclosed charge. So what I want to say is if you have twice as much charge on the plus, there should be twice as many lines coming out from it as ending up on the minus.
Yeah, that does make sense.
Because
Well,
looking at the picture, I mean, yeah.
if I make them equal charges, it depends like how many field lines you draw, though, right? Like, I don't know if this thing would illustrate your idea. But I think like if your process of drawing a field line is you just pick a vector really close to a positive charge and you follow the paths of those vectors, there are more paths that lead to the negative charge. Well, I don't know about that even. Hey, Thunder. Is there a difference in when this... Actually, I think the closer to equal they are, the more paths start from positive and end at negative. But if we double the positive, like in the problem, more of those paths go to infinity. Like there's a narrower kind of angle where you do come back towards the negative charge.
Do you think, like, relative to the positive charge, the critical change of behaviors at angle pi over 2 and negative pi over 2?
Yeah, looking at the picture, that's what I was thinking.
Which would
And
just it'd split it in half. It'd be like literally half the field lines go.
yeah, which is why I was thinking that 2-to-1 ratio on the charges, right? See, I don't know how this thing draws the lines, right? As you brought it in closer, it's not changing the number of lines coming out to the left from the plus sign, but it's changing the number on the right, isn't it? It looks, or isn't it? Maybe
As
it's not
I think
changing those either.
it always gets the same number of lines, I think. It seems like it at least.
So maybe the way it,
Can we make it do more?
I'm pretty sure it does the just a certain count, a certain even space around the charge. So it just
Yeah, probably, yeah.
how many of them? 10, 8, 12. There's 80 there, maybe, I don't know.
But there definitely is a significant difference in like
Try it with
between equal
4.
versus unequal. With 4
Try it
charges
with,
or
no, 4 times the charge.
oh 4
And
times
then
yeah.
in that case, it should be roughly
Ooh.
1/4.
Yeah, that does seem a bit like 45 degrees.
Oh, hell yeah. You did a trig.
I think it like this looks like a cardioid. I wonder if there's a way to work out like the polar curve of this.
Oh yeah, so now can you drag that blue one and like move it closer or further away and see if the angle that we're looking at is fixed?
Oh, it
It
seems like
kind
it's
of
changing
looks
a bit. Well, no, it's just scaling different. I think it's still the same angle.
maybe, yeah.
Which I feel like by symmetry it should have the same behavior, like the same kind of like general behavior regardless of how it's scaled. Huh. Okay. It's an interesting thought, like what that like boundary is. There must be a way to find it. I don't know exactly how you would though.
What if you change it back to 30?
Let's do that.
The positive one. What if you make it 30?
Oh, you know, I wonder if the angles would change if it's 1 over r squared. I wouldn't trust these numbers as exactly, maybe, but the trends, I guess, are still going to be the same. So for 30, that looks like pi over 3?
Yeah, it's hard to know. We just need some better programmer to write us some better software.
Yeah.
I happen
Come on.
to know one. Hey Fetza, yeah, we're doing electricity and magnetism. We're just looking at a visualizer for some fields, but this one isn't exactly perfect. But we're just looking at like some trends and how these two charge systems behave.
I mean, could this be open source? We could square something. We could get in that source and square it.
Maybe, I don't know. Yeah, java@falstad.com. You can ask them for their source code, maybe. uh, is that a geocaching.com? I don't know why they link their geocaching thing, but okay. I don't see a link, at least like a GitHub or anything. Licensing info. Okay. Yeah, it doesn't seem like it's open source, at least, not obviously.
You can take a look. If it's JavaScript, you can always get in a page and mess with this JavaScript.
Oh, yeah.
It's allowed. The browser lets you do it.
Pretty old page, I love it. Yeah, I found Physics and Depression is the one who showed me this site. There we go. Yeah, old websites are like they don't look as nice, but they're so much easier to navigate.
It's heresy, Don. Pure heresy.
I mean, I don't know. I
No, I'm
it's
right
right
there
on the
with you.
site. Like I think like Facebook is like a recent site that's changes their layout every 2 weeks.
Got to keep the elders guessing.
Yeah.
Can't tell you how many times I've helped folks with Facebook and I can't find themes anymore.
Oh gosh, I think Snapchat. I mean, it's not on a website, but Snapchat I think was the worst one for me. I think they're intentionally hard to use so that old people can't
Oh,
use
that
them.
was the worst. Oh my God. I have never, besides yesterday, hated an app so much. Oh my God. I mean, anything you think that the buttons are gonna do, that's the wrong button.
Yeah, and you just have to know to swipe. Like, oh, on this screen, you just swipe to the right, and you see this thing. It's like, how do I know to do that? I think I'm just slightly too old to understand how Snapchat works.
No, it's just terrible. It's just terrible.
um,
Did we draw the field line?
I mean, I'm taking. Oh, I think $5 maybe you're echoing.
Am I? Sorry,
Oh, it's good now. I don't know what
Oh,
happened.
they ask about the angle. They do ask about the angle.
There. Oh. Okay. But yeah, but between my crappy drawing and the website, I think we can say we've drawn the field lines. So for part B, choose a what? Draw a wisely chosen Gaussian surface that mainly follows these lines. Huh.
Wouldn't that be a plane?
Wait, what?
Wouldn't that be a plane in 3 dimensions? So from the positive charge in the y and z axis, or wait, yeah, in the y and z axis, a plane, that would be half the field lines, right? Split the circle in 2, field lines come out of the
I think we could work this in 2 dimensions. Or like it technically is three-dimensional, but we could just like kind of take a cross section of everything.
Oh yeah, that would be
I don't
easier.
know. I don't know what kind of surface we would want to draw though to get the angle.
I feel like it's a vertical line in this case.
I think we'd have to do a rectangle. Like it would have to be like a three-dimensional shape. But
Oh, I mean,
that
for the whole
idea.
surface, yeah, but at the point, at least.
is my microphone messing up? Because I see on the screen my number keeps flashing, but I'm not saying anything. So I don't know if my microphone's feeding back from the
It
audio
sometimes
here.
is.
Is it?
Yeah.
How do I fix that? Maybe I gotta get a headset or something so I'm not.
Oh yeah.
I'll
If you
get some
listen to
headphones or
speakers, it might be
something is what I'll
that.
do.
Okay. It's not like that bad, but it'd be nice.
Actually, I got some crappy headphones. Let me try them.
Okay.
I think I might be thinking of the problem differently from you. Let me reread it.
Oh yeah, it's not the first time I've read a problem wrong. Okay, my new bet is that we want to draw some kind of like fan-shaped thing. And the angle this fan sweeps out is going to be the important bit.
Okay, I got headphones, so it should be fixed.
Awesome, thank you. So yeah, we're looking at part B right now. I guess it needs to enclose charge. Well, do we want it to enclose a charge or not?
I forget how flux works. If it goes through both sides of the shape, or the 3D shape, or the 2D shape here, does that make it 0? So
Yeah.
some flux goes in, some flux goes out, and it net there's 0 in there. My interpretation of this is that I don't know how to think about it with a Gaussian surface, but that the field lines where the change of behavior between whether the field line goes towards the negative charge or off to infinity, I feel like those go straight up and down vertical away from the x-axis. So pi over 2 radians. But that's just based on the idea that half of the field lines from the positive 2q strength charge end up going to the negative q charge.
Mm.
And then geometrically, half of the around the point charge would be half that, half of a circle. And the best way to do that symmetrically, like we have, would be split it vertically. And I'm not sure if that's how physics works.
I try to think, like, I think the ratio between the two charges is important, because if we made the one on the left like 200q, the minus q is going to be like nearly insignificant, or like basically insignificant in comparison, and it may as well just be a point charge. And very few of the lines would go towards negative q, because like 200q is just so much more powerful.
I think it's going to be like we saw in the pictures, though, that it's going to be like pi divided by the ratio between the two charges.
Yeah, but I guess it's not. I feel like it's not going to be as simple as just like vertically in half. It would depend. You need some kind of like nice enough ratio of the two strengths to get pi over 2. And if we have 2q and minus q, maybe that is the right ratio, but I don't know how we would show that.
What about a half sphere, like your shape, but extend the blue portion to include the negative charge? And then the charge flux going in should be the amount going to Q. And then you should be able to geometrically maybe I'll draw a picture. Let me draw a picture.
Yeah. Because that, like, if we draw our surface not enclosing any charge, we should expect a 0 result for the flux. But if we do enclose charge, then it should be non-zero. Oops.
Almost. And paste it in the text channel. And this is pretty much your same picture. But I would choose this shape specifically with it being vertical.
Really?
just based on my hypothesis.
Oops, I did the wrong thing.
Or I suppose you could think about it in a general sense as well, but my hypothesis is that shape. Might
Yeah, I
be
guess I was
such a
thinking.
Gaussian surface.
I guess I was thinking we could call the angle like from 2q. Oops, that's not the brush, is it? Like we could call the angle like theta and try and figure out what theta must be. And if it happens to be pi over 2, then I guess you're right.
And I'm not so convinced like my thinking is right either. I was just thinking as you morph the shape of the blue thing, the total flux doesn't change, stays constant. So then what do you actually, or what do we actually use to figure anything if it just stays constant?
Well, for this situation where I'm closing only minus q, we do have I guess a negative flux if it's going into the shape, but not out of the shape. If we did like a shape on the complete opposite side of this 2q charge, we would have net zero flux because every arrow in has an arrow out. And it's not enclosing any charge. There has to be something we can like calculate here. Like we'd want e dot the length of this thing, that like first arc.
For a field line like that, is there like some conserved quantity or something? Like when you have a field line, something equals maybe 0 or some relation between things we might have. I guess I'm just a little unsure how the field lines work. I know I would draw them by following the vectors inside the field and just kind of get a general sense of where does that field line go. But what actually is the field line?
I think it's basically what you say, where if you have a vector field, you would choose somewhere close to that vector field to start, and then you travel along this vector, see where you end up, travel along whatever vector's at that point, and then see what vector's here, and then kind of build a bridge like that, I think are these vector fields. I'm not doing it particularly accurate with my red arrows, but if the vector field is like a river, it'd be like if you drop a leaf into one particular part of that river and see how it flows, I guess, is a metaphorical way.
So what if you consider a small sphere or a circle around the positive charges? And no, I lost it. Never mind.
No worries. Remember arc length. 2 pi r times theta over 2 pi which is just theta times r. That's right, in radians. And then by Gauss's law is equal to minus q over epsilon naught. I don't know if this means anything, but I'm just kind of blindly plugging stuff into Gauss's law, hoping for the best. What would it be interested in? Oh, did I just prove that the circumference of a circle is end up with the circumference? Or no, that's not the circumference of a circle, so sorry. Theta equals 2 pi r. I don't know what this means. I would want to get rid of the r. You know what? There's a minus sign here, because the flux is negative. I feel like it's something like what I've written, but I don't know how to interpret it. This is the thing that I got exactly. But I feel like we need to do some kind of calculation that's like what I did. Hey Obi, for Outer Wilds, uh, probably next Friday again. I might have stuff that gets scheduled that might like push it around though. I'm not sure exactly. If you want, I can put like a message in my Discord if and when I do figure it out. It'll be Wednesday or Friday, but I'm not sure exactly when or like which one of those. Yeah, I'm gonna try to do it once a week.
Yeah, I'm stuck on this problem.
What about this argument? I'm stuck on pi over 2. I won't let it go. Imagine this situation, or where you have the Gaussian surface around the negative charge, and a spherical one, and you grow it larger and larger and larger till it's getting asymptotically closer to the positive charge. During that whole time, it should have the same flux, negative q, or whatever flux you get from negative q. So when the circle finally hits the positive charge, that actually happens at pi over 2. But I feel like this will work for any ratio of charges. So we'd have to use some aspect of the geometry in thinking about the weirdness of that point right when it touches the surface. The point being the positive charge.
Yeah. I was thinking we'd keep the surface at a constant like r, like it starts a constant r away from the point charge, from the positive charge. As soon as you include it, that really changes your flux because you get all the field lines all around 2q. But yeah, like three-dimensionally, I think this would be like a sector of a sphere, but I think that I don't know if the sector of a sphere is even the right term, but like it's like a spherical cap.
Yeah, that's the one.
But the angle that defines that cap should be the same kind of all the way around. Like it should be the same theta, I think. Which is probably why I'm thinking it's okay to. Oh god, that's not even close to a cap.
Oh, I think it's definitely okay to think in 2 dimensions.
Okay. I don't know how you draw this. I'm not an artist. But
Draw the rest of the owl down.
yeah. It's such a good question, which like I have a hard time walking away from this, but I don't have an idea right now for how to either modify what I've done or come up with something better. But I feel like this is the right surface. I'm just not thinking about it the right way. Actually, it's not even a spherical cap. I don't know what the word is. But like a hollow spherical cap with a thickness, I guess. I don't know. It's not that important though.
I'm a little lost too.
Because I'm trying to like vary theta and figure out that should flip the direction, or something should get flipped once you get to a certain value of theta. And that's how you know you want to cut theta off there.
Yeah, I follow on that conceptually.
But
I'm having a hard time knowing what that actual thing is. I think it's the field line in question, the one that follows that particular border point between the behaviors. But then I wouldn't know how to express that mathematically to think about a surface getting to that point. Because we'd have to have some algebraic statement that we can manipulate. Otherwise, what can we do?
Exactly, yeah. I'm not sure. So maybe we should call the session here for the day because we're around the 2-hour mark anyway. So I'm kind of out of ideas with this one for now.
I'm good with that. If you're good with that.
I remember learning electric field was, you could think of it as, sorry, flux. Flux was like the intensity of the electric field, right? So you could kind of think of it as like the number of field lines per unit area. That's kind of a hand wavy way to describe flux, but I remember hearing that, and I think it sometimes when you think about flux that way, it makes it easier to think about things. Or it gives you a different way of thinking about things, and that's why I thought maybe if there's twice the charge, you've got twice the flux, right? Because the field of a point charge is proportional to the charge itself, right? K times Q over R squared. So if you're kind of in a little sphere around a point charge, the field strength is proportional to the charge. Yeah, I don't know.
Yeah, this is gonna bother me.
Flux is like density of field lines, right?
I think I've heard that analogy before.
It kind of conflicts with how I think about it, but like I can like justify. Like I think that's not a bad way of explaining it.
I think maybe I'm confused. I think I've heard fluxes, like analogy-wise, similar to the number of field lines, so independent of surface area. But happy to be wrong. Because I feel like if it was dependent on surface area, as you make the Gaussian surface larger, the flux should change, but we know that's not the case. But that's just quibbling about analogies and language, I think.
Yeah, I think I agree with you. So if you go out twice as far, if you make the sphere twice as big, you've got much more surface area, but you have the same number of field lines, don't you? So it's not, yeah. I don't know. I'm gonna think
Yeah.
about it some more.
Same. Thank you both for being here, though. I guess, or not. I guess, but yes, thank you. I'll
Thanks for
probably do
having
some math help for a bit. Yeah.
Before we go, let me ask you, is my microphone still, are you still getting feedback from me? Because I see that little thing flashing all the time.
No, I hear you maybe like tapping things or something like that, but it's not like the same feedback that was happening before.
It's probably my neighbors upstairs pacing. I can hear the ceiling creaking.
Oh, it could be that.
doing good old daytime pacing. All right, see you both.
Yeah, see ya.
All right. Yep. Thanks, Don.
Thank you. Okay. Awesome. That was a nice little session there. Let me get this thing copied into the Discord. Just so we have a record of at least the notes that I took. Some more thought. Ooh. That's not what I want. Wait, yeah, that is what I want. Okay. Cool. I want to figure that problem out so bad, but it's not gonna come to me quite yet. Let me get some music going, and I need to switch my title and category. What music am I going to get going? Let's just get that music going, why not? And internet. Math. Okay, Twitch info is updated. Let me update my YouTube info. It only takes 2 seconds, but it's still like 2 more seconds than I would normally want to spend updating my YouTube info. Try to work out how to do that. Yeah, there's like push to talk where your mic only transmits while you're holding a certain key of your choice. So if I'm like playing a game with someone that, or with like another streamer, I'm usually on push to talk. Towards the end, once you put your headphones on, it was pretty much fine for me at least. Math time, yeah, hard luck. So I'm still down to switch over to Phasmo in like an hour, I guess, or so, or maybe even sooner if people don't have questions. But I thought there'd be, I feel like there'd be someone with a question. Who was asking earlier? Palpo. I wonder if they're still here. At Pauco. I'm gonna type them in chat in case they have the stream on mute. Taking math questions now. Sounds good, hard locked. Questions now. Been lurking. I appreciate you. Okay. We're all switched over. You know, I want to listen to my. I assume it hasn't. All right, I assume it's actually no. I need to check my this mic here in Discord because it's giving me issues before, and I thought it solved them, but apparently it's still having problems. So I need to figure that out. Maybe take a quick look through Reddit and just see if there's like some question that someone posted online. Oh, I thought it said piss. Or maybe it does say piss and it's a capital I. Wow, this person is posting a bunch of questions. Let's look at this one. Someone already answered though. Sorry, I'm still thinking about the flux problem. Now I wonder if you had an entire sphere, if that's worth examining, but I don't. Problems. It's gonna bother me. I feel like I'm so close to figuring it out. Okay, sounds good, Fembox. Thank you for being conscious of that. Hmm. Oh, you know what? I wonder. That's probably the person who joined in Discord. Let me add them in Discord too. No worries. Okay. Because I want to make sure I don't forget about the person who had a question before in the stream. But if they had to leave or something, then that is what it is. Really aren't. I mean, there's actually a lot of threads that have been posted to this thing, but they're getting answered quick. Double integral. Oh, geez. Prove this thing over the triangle x equals 0, y equals 0, x plus y equals 1 is gamma. What? Oh, this is... Oh, I don't know if I can do this double integral. Okay, I haven't done a double integral this hard. Never mind. Maybe, I'm not seeing a whole ton on Reddit. I mean, I could look at the math Discord. Let's try the math Discord, I guess. Oh, what did you do, Discord? What are you... Okay. I don't know why I did that, but... Oh god. Why, like... I feel like my Discord window is being super weird. Okay, there. Oh. That's an interesting, like, type of question to ask. I kind of like this. So yeah, you have 33 techs, and you have to divide them up for each division based on the number of people in that division. So the total number of employees is 240 plus 330 plus 380 plus 410, which is a job for Wolfram Alpha. $240 plus 330 plus 380 plus 410. And for the one with 240 employees, 1360. Thanks. I need to fix this window now. There we go. Okay. No Wolfram? Well, we can't all be as smart as you, Fembox. That doesn't seem right. Oh, yeah, that's the proportion for that's like the percent of the employees that the 240 person department should get. But we multiply it by the number of techs, which is 33. 5.82. So I agree with this person's first answer. Okay, this time I will do it mentally also. 240 plus 330 is 570. Yeah, plus 570 plus 380 is 950. Yeah, 950 plus 410. 1360? Oh yeah, we get the same thing. So maybe we both made the same mistake, but for 330 employees is next. I get 8.01 instead of 8.00, I guess. 380. 9.22 is what they get. 410. I get 9.95, which they also get. It must be the rounding on the 330, I guess, if it's wrong. What is this number on the bottom? Is that 33 divided by... No, it shouldn't be. Oh, yeah, you're right, SPQ. So, by the way, if anyone here doesn't know, SPQ's been streaming. Check him out. 1360 over 33. Oh, okay. Division with 330 employees should get rounded up to 8.0. Oh, that's not an 8. That's an 8. 8.00. That would be kind of lame if the computer. Like I thought they normally, like, all these homework software things will accept things within like 5% of the answer. There's some kind of like error tolerance. Close enough. So I wonder if something else is off. And hey, Kim Willis. Yeah, I wonder if I should update that text, like, because playing math is a weird phrasing, but What else could be wrong with it? I'm just gonna leave it there. Math is the only game worth playing. The positivity set. Oh wait, this is a translation. El conjunto de positividad de F. F, I guess, if it's Spanish. Positivity set. I wonder what conjunto means. Because positivity set, I've never heard that term before. I wonder if it's just something that I haven't learned, or if it is indeed like a... set of positivity of F? Whole, joint, ensemble, body, combined, aggregate, grouping. I think it's chorus. No, F of X be the solution of problems. Like, would I know how to solve this differential equation? Oh, it's first order. So yeah. Could always do an integrating factor. I just don't know if that's what they want. The positivity, like, is that just the numbers where F is positive? Like the domain, I guess? I'm just going to plug this Diffie Q into Wolfram Alpha, I think, and just see what solution it gives. Want to know F... I'm interpreting that as like what values in the pre-image give you positive values in the image. I'm attaching my own interpretation to your notation there, though, SPQ, so I might be grossly misinterpreting you. So those dogs work out, you just put IG or K into it. And make sure that even if you can't. I don't know if you can do a matrix version of first order. I'm pretty sure for any second order, you can always break it down into a system of first orders, though, which would involve matrices. So do we get something completely gross? That's not gross. But it's always positive, though. Unless our initial condition is negative. Y of 0 is negative 1. Why is there a +2 on the other? That looks weird. Okay, so... Actually, before I look at this, we should... There's a new post in this one that I responded to before. Okay. Looks like that was the issue. Should I work out the problem before I respond to them though. Yeah, let's work out the problem first. I'll be able to get to the answer that Wolfram gets here. Plus we need to apply the initial condition to figure out what C is. Y prime. One plus x squared y equals, that was 2x? I mean, yeah, 2x over 1 plus x squared. Okay. So the integrating factor is e to the integral of that thing? Yeah. So I don't remember how this thing is derived. I just have this formula memorized, which I feel like I feel like it's an issue, but I'm too lazy to actually fix it. So you do u equals 1 plus x squared, and you get 1/2 the integral of 1 over u. So like that, which is just 1 plus x squared is the 1/2. I like that. So y is equal to 1 over the integrating factor times the integral of integrating factor times that. Okay. And add plus c on prematurely for this. So remember that this gets multiplied by c as well. So what does this thing integrate to? One plus x squared to the 1/2 dx plus c. Do the same u sub 2x dx. So we're going to get the integral of 1 over u, which integrates to 2 root u. I'm mixing my fraction notation and radical notation, but, you know, sue me. Oh, that's where the 2 comes from. Funny. Because that cancels with that. Okay, so if we want to plug in our initial condition, y of 0 is equal to -1 is equal to 2 plus c over root 1 plus 0. -1 equals 2 plus c. -3 equals c. So y is 2 plus... 2 minus 3 over root 1 plus x squared. Okay. So you set your assignment exam for your astrogeochemical molecular stuff, and looking at the feedback, I scored 24 out of 25 for part 1. Nice. Got a lot of info in your answers for the key bits. Part 2 and 3, so that's going to have a good score. Hey, I mean, that's a great start. Hopefully, you, oh my God, I can't talk. Hopefully you passed it. Fingers crossed for you. And if I was in that class, even if I didn't pass it, I'd be bragging to everyone about my astrogeochemical molecular class. It's easy. Well, don't tell people that. Tell people it's really hard. Carbon finds an element. It's fair. Carbon does bind with a lot of stuff, right? I'm gonna ask the person that. My guess is that for the last line there for my final answer on the board, it's where what values of x give you a positive y. So you let it be greater than 0 and solve it for x. Hey Mangoes, thanks for the work. Thank you, Camel. Camel Ellis. The end. Thank you so much for the prime, Camel Ellis. Oh yeah, you're one of the OG founders badge havers as well. I appreciate it. OG baby. Oh yeah, I did hit 800 followers last stream. I need to set a new goal. You know what, funny, I think the 800th follower was another one of Brian's accounts because it was Noble Penniless, so I think Brian's been a few follows for me now with all his accounts, and I'm not gonna complain about it. Let me set a new goal because I know I'm gonna forget if I don't. I'm gonna put it on 900, I guess. I don't really know if there's like a good thing to set for a goal, but 900 seems reasonable. It'd be cool to hit 1,000. So it's a nice like round number, but let's not get too crazy. New goal, 900. Start goal. Here we go. Positive images, okay. Looks like this person is gonna work on it. We'll jump in if they like have to leave or something, I guess. But this person doesn't need two like people trying to teach them problems, so for now I'm just gonna let it be. This is some calculator work right here. It definitely should not be 87.7. They probably aren't doing 1 minus. if they're using a Z table, well, let me just look up a table. Stats Z table. Oh wait, we need to we need to find the Z score for this thing. I assume it's multiple choice, yeah. They said they got 87.70, so. We gotta do 14 minus 8.7 over 3.9. minus 8.7 over 3.9. That's our Z score, 1.35 or 1.36. .9131, and we do 1 minus that. Go away, pop up, your iguana. 9131, 9131, 9131. 1 minus 0.9131, 8.0869. I don't know where they got, because I was just thinking that 87.1 minus 0.87 isn't right. So I don't know how they got that 87.7 number, because it's not just as simple as forgetting to do 1 minus that. That's like, 12.3. But yeah, I mean, the 14 is well above your mean. So you definitely should not have 87.7. Oh god. Set the follower goal to 1/10 to the -1 times 1 over the square root of 10 to the -1 squared. That's just 1,000. I could do that, to be honest. I know we're like, I don't know, like, is one of them better for engagement than the other? Yeah, exactly, SPQ. It's above the mean. We're asking for greater than 14. So it definitely can't be more than 50%. Do you use tables or a calculator? Because that's kind of like the big issue with stats classes, is it gets taught, like the method that you solve these is pretty different depending on the class. Okay, yeah, this person has the right setup. Looks like that person is still working on it. Dude, this thing is actually still, I'm kind of surprised there's this many threads open over summer. What time is it? Okay, 3:40. In 20 minutes or so, I'm going to switch over to playing some games. So I want to get some Phasmophobia in. It's fine if you go longer. Nah, I mean, I was just hoping the person who checked in earlier in chat would come back to ask their question. It seemed like they might have had to go for the day, though, or something, so just kind of like burning time to see if they do come back. the Boolean expression by the table. Ooh. This is kind of a neat one. You have to create a Boolean expression that matches this truth table. Okay, my initial guess is not A and B, like not parentheses A and B, or C. No, that fails on the second line. Let me make this bigger. It might be hard to read on stream. I feel like there's got to be a not and somewhere in here. I like that approach, SPQ. I wonder if you could actually start from that and like boil it down somehow. Like, you know, use De Morgan's and like simplify things or something. For sure? Okay. Or is it not ending all three of these? If we do not, parentheses, A and B, I guess we stick another not on the outside, and I guess A and B and C not. No, that wouldn't be right. I made to just actually write this out and stop being lazy. It's kind of a fun like format for a puzzle. A XOR B and C. Really? Doesn't that fail the first line? No worries. We need some kind of negation somewhere to deal with the first line. A is kind of negation invariant. Oh, as in there's... Okay, yeah, because A is 0 here, you get 1 for the output, but A is 1 here, and you get 1 for the output. B, if and only if C? I don't know what if and only if does logically like this. I didn't learn if and only if for circuits. And I'm interpreting this as circuits, I guess. I mean, can you still do a truth table with if and only if? I don't know what that truth table is. I'm doing truth tables with if. You think you're still wrong? Okay. So what if we did A or not B and C? No, that will fail the second line again. This freaking second line. Not A and B, X or C? No, that'll fail the third line. It's just B if and only if C? Is if and only if and? Oh, duh, it is just, no. Oh. That makes sense. Hey, YKAP, how's it going? B equals 0. It's fine for these second and third lines. I think Finvox is right. I wonder if this person has if and only if. I feel like I didn't learn that in this context. What do you study? I have a bachelor's in applied math, YKAP. I got it like 5 years ago. I'm not currently a student. If B, then C, and if C, then B. I mean, we could just ask them, I guess. They might have if and only if. I'm just playing like with my class. Oh wait, did someone else get? Oh, someone else beat me to it. That's why I don't like. I don't know. Now I don't want to say anything because I think too many answers is like almost as bad as no answers. I feel like, or it can be like just confusing. S equals 1. Can say that. Okay, yeah, this person is getting to that thing that SPQ pointed out. Oh, thanks, YKAP. So yeah, when things are slow in chat, or like when there's a question from chat, I tend to either look for questions out on the internet, like I am now, or I'll do some kind of studying of electricity and magnetism, or abstract algebra. That's what I've been doing. Do you think math and computer science is important? Oh yeah. I mean, it depends on the type of computer science exactly you'd be doing, but there are some types of computer science that are really math reliant. Data science? Oh yeah, I think you're gonna need math for data science, if nothing else, like statistics. But I would imagine that like there's gonna be like potentially linear algebra involved in data science. Everyone wants machine learning. Yes, BQ, that is the hot topic. It's like if it, and actually that's a good thing. Like with machine learning, if you want to do data science with machine learning, at least the theory of machine learning is very reliant on linear algebra. I think if you're actually just like what's the word? Using like an existing machine learning algorithm, maybe you don't need to know it. If you want to make a machine learning algorithm, you would need a lot of it, as far as I know. You want to learn ML? I mean, you've been working with ML a lot, right, Hardlocked? Are you trying to learn like how ML actually works, or just like how to use it, I guess? I don't know either, but I'm just like curious. You're bad in algebra? I mean, it's hard to give you like general advice for YKP because I don't know that much about it myself, and it also depends on the like exact thing that you would end up doing, which it's hard to predict the future. You probably don't even know what you're gonna like, what kind of job that you would get after getting a degree or something like that. So I have a hard time giving advice on stuff like that because it's like you probably could find some kind of niche where you don't need it, but you have more options in front of you if you do know it, is maybe what I can say. It's not even hard math, it's just like, what are they talking about? Yeah, I have a book about machine learning too, like at least the theory of it. I've only read the first few pages, unfortunately. I need to actually get around to reading it at some point. And they have some pretty crazy notation to express their ideas. Data engineers don't use math a lot. I don't know. I think that the best advice that I could give you, YKAP, because I don't know this for myself, I would go on to like a job what website, just like, and search up the title data science, or like just search up like data science, data engineer, potential job titles that you might be interested in, assuming that you're doing this with a career goal in mind, and look at what those employers require, like what kind of like packages and languages or like tasks they'll have you do, and that should give you a hint as to how like much math, or how much you should care about the math part of it. If you're doing a data science degree, they're probably going to make you do math regardless of some kind. But you could probably care less about, or you don't have to care as much about certain classes maybe if it's not relevant to the types of jobs you're going to go for. I think that's kind of like the best thing that I could tell you, because I don't know myself. Analysis and algebra in your first year. Okay, yeah, that's pretty like typical stuff to make like math students study in general. I don't know what I'm trying to say though. Yeah, so I for your degree, you're gonna have to know at least a certain amount of math. You're probably not gonna have to care about every last math class that you take. You're probably not gonna like actually use every last math class when you go to actually get a job. What did I say the score was? 1.36? Yeah, 1.36. No worries, YKP. I wish I could give you better advice that's more customized to you, but it's just like I would rather tell you where to get good information than attempt to give you good information off the top of my head. That may or may not be right. When I look up 1.36 in a Z table, I get 0.9131. P of x less than 14 is equal to, let me actually, I guess I'll LaTeX this. P of x less than is just less than symbol. I don't do anything special. I hope. 0.9131. So to get the desired answer, we do p of x greater than 14 equal to 1 minus p of x less than 14 equals 1 minus 0.9131 equals 0.0869. Okay. Oh wait, 7. Yeah, I'm willing to call that like a rounding thing because I didn't get exactly 1.36 for the z-score, but those tables make you round to the second decimal. Those are close enough that I don't think I'm concerned personally. Oh wait, you're saying, oh, I think I get what you're saying now. This person is doing the percent conversion wrong? That could be it too. Does the percent in LaTeX, is that gonna, do I have to escape that? Let's find out. Yeah, it gives me an error. There we go. Let me see, someone posted something in the Discord. Okay, just a reading group thing. Look at that later. All right, so that person popped in chat before. Unfortunately, hasn't gotten back to me. We might take this opportunity to switch over to Phasmophobia. See how lucky you're around, or I'll send you a Discord message if I don't see you type in chat. I'm gonna take like maybe a 2-minute break to go use the bathroom and stuff, but I'm down to switch over to Phasmo. Is there anyone that I can recommend people who want to watch math to go watch? Nah, I don't have anyone on who's doing math right now, unfortunately. Set in the percent conversion to my answer to hopefully address that person if they did do that percent part wrong. I'm carrying the math torch. Unfortunately, I'm about to drop it. So yeah, I'm gonna cut the YouTube stream off here. So if you're on YouTube, I appreciate you. I'll be back on YouTube on Tuesday. And goodbye, YouTube.